In this query, you have to find the name of employees who work on all the projects controlled by department number 5. So basically what the query says is, there's a department where the department number is 5. You have to find out all the projects that are handled by department number 5. So I'll assume that project 1, project 2 and project number 3 are handled by department number 5. So you have to find a list or the name of those employees who work on all this project, project 1 and project 2 and project 3. Okay, name of those employees who work on all the projects controlled by department number 5, that is project number 1 and project number 2 and project number 3. We go to the database schema. So what information is given to you? You have just the department number. You have to first find out which are the projects that are controlled by department number 5. This information is available in the projects relation. Alright. So here, if you look at this table, the department number will be mentioned and the project numbers will be mentioned. Department number, project number. Right. So once you pick up this information, then you find out which employee work on all the projects. Now that information is available in the works on relation. So once you get information about employees working on all the projects based upon the ESSN and the SSN in the employee table, you pick up the name of the employees. So very simple. We select those tuples where the department number is equals to 5. Okay. So we get product X, product Y, product Z. So department number 5 handles these 3 projects, project number 1, project number 2 and project number 3, where the name of the project is product X, product Y and product Z. Once you have this information, your next task is to find out which employees work on all these projects. That information you will be able to get from the works on relation. We'll just try to do a small mapping. You see that this particular employee works on project 1 and also works on project 2, but is not working on project 3. This employee works only on project 3. This employee is also working on 1 and on 2. Whereas this employee works only on project 2 and project 3. Our requirement is to find out list of all the employees working on all the projects. Looking at the database state, it is not possible. So does it mean that there is no output? No. This is a partial snapshot of the database. There might be some entries in the table which will fulfill the requirement. There might be some employees who are working on 1 and 2 and 3, all the 3 projects. So when we write our query should be a generalized query that fetches us our result. If there is no information in the table, the output of the query should be no records found. But the query must be a generalized query. Okay? We will see how we can do it. From the first table, that is the project table, I will select those tuples where D number equals to 5. Okay, so project select D num equals to 5. So when I do this, I get this 3 tuples, right? So this is a partial relational algebraic expression. Then what I do is I apply a project operation over here and I say project the P numbers, P number. So basically I am picking up this particular attribute. Okay, and then so the output would be something like this, P number 1, 2, 3, and then I'll perform a rename operation and I'll rename this as P and O. Now why I'm renaming this attribute, I will tell as I go ahead. Okay, and I store this information into a temporary relation called as department 5 projects. Okay, so this would be my table. Final table over here according to this particular query would be this. So after this step, I have achieved all the projects managed by department number 5. Now next step is to identify who is working on all these 3 projects, which are the employees working on project 1 and 2 and 3. So referring to the works on table, now over here what I will do is I will pick up the required information. I require which employee working on which project. So I will apply a project operation and pick up these 2 attributes. Okay, so works on applying the project operation, I pick up the ESSN and P number. So this is what I get, ESSN, P number, excluding the R's. Next I rename this. Okay, I will rename this as, rename it as SSN and P number, P and O. So ESSN renamed as SSN, P number as it is. And I store this into a temporary relation, EMP project. This would be my table. Okay, this temporary table is shown over here. In the previous slide, I tried to find out which are the project numbers that are controlled by department 5. In this query, I have found out which are the employees who are working on all the projects. Now I will perform a simple operation. I will refer to the employee project table and the department 5 table. Now this was the output of the first query, that is all the projects controlled by department 5. Here is a list of all the employees working on whichever projects. Now a simple operation, that is a divide operation between employee project and department 5 projects, will give me a ESSN who is working on 1 and 2 and 3. We have already seen the working of a the division operation. Okay. So finally the output of this would be SSN or ESSN, who is working on all the projects. So my query would be EMP underscore project divide by department 5 projects, which gives me the ESSN. So I store this into a temporary table, result EMP SSN. So this is a list of those employee ID who are working on all the projects controlled by department 5. Now my final thing is, take this EMPs, perform a natural join with the employee table, which will give you the name of those employees, right? So result underscore EMP underscore SSNS natural join with employee. Okay, and this you store, or rather than storing it, what you can do is, once you get the output, what you do is you project the L name and the F name of those employees, and then you store it into a temporary relation or a final relation result.